Today we are going to start a very important chapter in nuclear physics, and this is actually the study of elementary particles. In fact, the field of study of elementary particle is so vivid that in higher physics we also called it particle physics. But uh, I have dealt these elementary particles just as a chapter of nuclear physics. So this is our final chapter on nuclear physics, and I hope you will enjoy the lectures on these elementary particles. In fact, the problems concerning the elementary particles are today the focus of interest and of research for the experimental as well as the theoretical physicists. In fact, ever since the evolution of scientific thought, one of the most fascinating areas of physical researches has been the study of ultimate structure of matter. At the start of the 19th century, you know, Dalton put forward his atomic hypothesis in order to explain the course of chemical reaction and processes and the structure of molecules. In fact, according to Dalton, an atom is the ultimate constituent of matter. But in science, nothing is permanent. So, very soon, it was realized that the Dalton's idea is not correct. But it was found that atom also possesses a rich structure. By the end of the 19th century, in 1897, J.J. Thomson firmly established the existence of a particle which is called electron. And actually this electron is the most important elementary particle, and now it is classified as a fundamental particle and that it is an essential constituent of all atoms. In fact, the studies and the discoveries of what are called elementary fundamental particles started after the completion of the structural picture of the atom, in which Rutherford's experiments and Bohr's ideas in early 20th century established that the atom considered as a positively charged nucleus, and the electrons revolve around it. In fact, earlier experiments on radioactivity conducted by the Mr. and Mrs. Curie and Rutherford indicated that the nucleus could be divided. In fact, you have studied definitely the famous Rutherford scattering experiment, and from that Rutherford scattering experiment it was found that actually nucleus is a very small part of our atom, centered at the center of the atom, and it possesses positive charge. This was the finding of Rutherford's alpha scattering experiment. In fact, after the discovery of proton by Goldstein, it was found that actually the positive charge of the nucleus is nothing but it is simply the charge of the proton. And after that, in 1932, James Chadwick discovered a neutral particle which is called neutron, and finally it was proved that actually our nucleus is composed of two particles, and those two particles are protons and neutrons. So you can say that the atomic picture become quite clear in the early 1930s, and the atomic scene was found to have only 4 characters, and those 4 characters was actually electron, proton, neutron and photon. But from where this photon actually comes? In fact, the investigation of electromagnetic phenomena suggested that the atom has an internal structure, and at that time the typical phototype of elementary particle was electron. The problem of the dualistic nature of matter was resolved by the quantum theory of fields, and the elementary particles are nothing but the quanta of corresponding field. So actually, while we see the elementary particles is the basis to the understanding of radiation phenomena, or one may regard any kind of radiation as a flux of elementary particles. So in fact, photon is the quantum of radiation, and that it is the building block of electromagnetic field. In fact, it is uncharged and has zero rest mass, but it is the carrier of electromagnetic energy. Okay. In fact, this photon actually determines the structure of atoms, molecules, solids, and liquids. Okay. In fact, in 1932, another particle called positron was discovered. And this positron is what? Actually, this positron is nothing. This is simply the anti-particle of the electron. It has actually all properties similar to electron, but its charge is positive, although the value of charge of positron is same as that of the electron, but the nature of charge of positron is just opposite to the nature of charge of electron, and this is called anti-electron or anti-particle of electron, you can say. In fact, this positron was discovered by Anderson in cosmic ray showers. Actually, this particle is an anti-particle of electron, as I have told you, and had the status of being the first anti-particle to be discovered. Okay. In fact, Dirac had theoretically proved the existence of this particle in connection with his relativistic theory of electron, but it would be discovered only in 1932. Dirac has actually taken just a hypothesis for this particle. So actually there is a existence of antimatter, and so in this condition you can say that as a whole, when we consider that there are particles which makes actually the matter and antimatter, then actually there will be 7 particles. In fact, positron, antiproton, antineutron, these are actually the antimatters. And apart from this, you have seen that there are 4 particles: electron, proton and neutron, and photon, which are actually the building block of our matter and radiation. So you can say that 7 particles: electron, proton, neutron, anti-electron, which is called positron, antiproton, antineutron, and photon. These 7 particles actually constitute matter and antimatter. Okay. In fact, apart from this, in 1935, Yukawa, who was actually a famous Japanese scientist, in a bid to explain the origin of the strong nuclear force which holds the nucleons together in such a small volume as that of the nucleus, he actually proposed that this nuclear force is mediated by a particle, and that particle is called meson, or you can say the pi meson or the pion. Okay. He was tempted to put forward his so-called meson field theory of nuclear forces, by the success with which electromagnetic forces could be explained in terms of the field quantum of electromagnetic field, the photon. He assumed that the nuclear forces are the result of exchange of field quantum of nuclear force, and that field quantum of nuclear force is called meson. So you can say, just as the electromagnetic interaction is mediated by photon, or the photon is the field quanta of electromagnetic interaction, just like that the meson is the field quanta of a strong nuclear interaction. Okay. In fact, Yukawa theoretically predicted this uh, Meson in 1936, and also proposed the mass of this pi meson, its spin, everything. In fact, it was predicted that mass of this pi meson is just 207 times of mass of electron, and it is just a half spin particle, and so it is just a fermion. Okay. Now, in fact, the recent development of the elementary particle, it is seen that the fundamental constituent of matter are three generations of leptons, okay, and the three generations of quarks. So you can say that the recent studies actually says that the fundamental constituent of matter are three generations of leptons and three generations of quarks. Okay. In fact, according to quantum field theory, the forces between the fundamental constituents of matter arise due to the exchange of gauge bosons. Okay. And so you can say that the gauge bosons are actually the mediating particle, or this is the exchange particle due to which the forces between the matter, different parts of the matter arises. In fact, the mediators of the fundamental forces are in fact gravitons, photon, bosons, and in the category of bosons there are W plus boson, W minus boson, and Z0 boson. And apart from this, there are 8 colored gluons. Okay, and these are actually the mediating particles of fundamental interactions. You will see later on when we will discuss the 4 fundamental interaction, then you will see that these gravitons are the particles responsible for the gravitational interaction. Photon is the particle of the electromagnetic interaction, and these bosons are actually the mediating particle for the weak interactions. And in fact, for strong interactions, the gluons or the quarks is the mediating particles. You will see later on in very detail in this chapter. So you can say the mediators of the fundamental forces are graviton, photon, bosons, and the gluons. In fact, these gluons and quarks are not seen as free particles, and it is hoped that it will be never exist freely, and so it will be never detected freely. In fact, the term, when you say the fundamental particle, then it will be just a matter of discussion that these elementary particles are of fundamental nature or not. In fact, the fundamental, the name fundamental, strange, elementary, these different names are used for these particles. So, in fact, the fundamental, the word fundamental implies that the particles are the basic building block of matter. But instability of most of the particle indicates that the great majority are certainly not actually the permanent or stable. So it is true that their behavior was strange in early 1950, but it is much less now. Now the behavior of all these particles are almost known. So now the term strange is not very appropriate to use for these particles. So for the want of better one, the term elementary particle is now commonly used, because when you say fundamental, it means that particle will be not built of other particles. But you can see when we will study in this elementary particle chapter the concept of quarks, then you will see that actually protons and neutrons are quarks, and proton is not a fundamental particle, neutron is also not a fundamental particle, because fundamental particle means the particle which will have no structure, a structureless particle. But we will see in our discussion that actually this proton has a particular structure. It is actually made up of 3 quarks. Here I have written UUD. In fact, this U represents the the upward quark, this U, again U, that is upward quark, and D for the dawn. So proton has a structure. This is its structure is UUD. Similarly, neutron has also an internal structure. This is actually DDU. So the word fundamental particle is not very appropriate. So I have told you that the adjective elementary particle will be actually suitable. So I have told you that for the want of better one, the term elementary particle is now commonly used. So these particles are elementary in much of the same sense as are chemical elements. Okay. And in fact, in India, the concept of the study of the elementary particle was started in very early stage, or very before the discussion of scientific world. In fact, according to the in ancient Indian literature, the physical world is composed of 5 bhutas. When you say bhutas, bhut means basic elements, and according to the Indian saints, those 5 bhutas were what? Those were chiti. Chiti means earth, and up means water. Third one is called tejas, which means fire. Fourth one is called vayu, which is air, and the fifth one is akash, that is called ether. Okay, or in fact, the famous poet Tulsidas has written in his Ramcharitmanas a very important line that Chitijal Pavak Gagan Samira Panch Rachitya Adham Sarira. Chiti, Jal, Pavak, Gagan, Samira. Actually, these 5 elements theory of matter is based upon the fact that our senses are being affected by the bhutas in 5 different ways. Okay, so these elements were not considered as ordinary earth, water, fire, air, and ether, but as basic principles. Okay, so these may represent the solid, liquid, plasma, gaseous, and fluid states of matter. So when you say, in fact, chiti, that is chiti means you can say, when you say chiti, that means actually solid. Okay, and when you say jal means in fact liquid. Okay, chiti jal pavak. When you say pavak, that represents actually plasma state. Okay, that represents plasma. Okay, and pavak. Gagan, that gagan actually represents the gaseous, you can say gas. Okay, and samira, Chitijal Pavak Gagan Samira. Gagan Samira, and Samira represents actually the filled states of matter. This represents filled states of matter. In fact, the idea of elementary particle in Indian philosophy is rooted in very ancient period. A famous saint known as Kanad was first of all given the idea of Kan. Kan means particle, and this scientific world after that discovered so many elementary particles. So, this is a very interesting chapter and you will enjoy it definitely. In this introductory lecture, I have just introduced you to this fascinating world of this elementary particle. But in the forthcoming lecture, first of all, we will see the classification of these elementary particles on scientific basis, and after that we will deal this complete chapter in step by step in different lectures.